So you've done a lot of work in natural language processing. Why specifically that? I mean, what drove you towards natural language processing subdomain of machine learning itself?
Mhm. I guess because it's very difficult. I mean,
Yeah.
because when you need to decide, okay, that's the thing that I want to research about.
Hmm.
The more difficult, the better, because I mean, you
Yeah.
can do more things, more exciting things. Okay, you do not take the easy path because I mean, otherwise you I mean, that's nice if you want, but in my case, just okay, natural language processing is just so exciting because we are working with some of the most complex things in artificial intelligence, which is language. And I mean, if you take a look at the results, yeah, now with these new technologies, we are able to do some fancy things, but the natural language processing problems are far from being solved, and we are still
Yeah.
how to do that. And I guess that artificial intelligence has a lot of things, a lot of to do with natural language processing, because in the end, we are if we are trying to replicate a human intelligence, something like that, or to trying to build up something similar, if you think about that, we speak languages. When we think, we are using language. When we communicate, we are using language. When I want to express myself, when I want to decide which kind of person I want to be, all of these things they are discussed by means of language. So I guess that if you want to solve, or if you want to move on with artificial intelligence, that's basically about language, or language is one of the most important pieces. So it was just exciting. It was just exciting at the time. It is exciting right now.
How,
So I guess that's because I'm so engaged with natural language processing.
how far along do you think we are in the work done in natural language processing?
I guess that, I mean, in natural language processing, when you research the history of this field of natural language processing, and this is also true of machine learning, but more about natural language processing, there are different waves, okay? And usually we are discussing if statistical methodologies are better, or if more linguistic methodologies are better. Okay, this is the discussion between this Chomsky approach of no, we are using, we have this grammar of the language in mind. So with these linguistic and grammatical rules, we are going to be able to solve the natural language processing problem. Or the other way is just, no, just give me a bunch of data and I will learn by means of machine learning and statistical techniques, things from this data,
Right.
and we try to solve that. There are different ways. So sometimes we see that we understand that no, we need linguistics. Linguistics is the best way of solving that. It does not work. Some 10 years after, a new statistical approach is discovered. So, okay, now the statistical is on top. So you just need the statistics. So right now, I guess that we are in this wave in which we are using statistics on top of linguistics. We started to get really impressive results by means of statistics, and we started to think, okay, that's it. We have solved natural language processing. We have deep learning. We have these really good techniques, really expensive techniques, but really good ones like transformers, GPT-2, GPT-3, and these kind of things. Google is working on that. OpenAI is working on that. Everyone is working on that. So that's the way of solving things, okay? And now we are starting to face the same problem again, that these statistical techniques are great. We are able to do really nice things that I couldn't even imagine when I was doing my PhD in natural language processing. But you see that we are not actually solving the problem. Even with this GPT-3, when you start to dig in a little bit with it, when you start to try to play with that, you see the problems, okay? And you see that no matter how many data you have, it seems that we require some kind of linguistics over there. So I guess that now we are in the phase in which this new wave of statistics is going down, and we are starting to pay attention again to linguistics. Okay, this is a really heated discussion in natural language processing. Depending to who you interview, I guess that no, forget about linguistics, just go with the statistics. Or if you interview these Chomsky fans, they are going to tell you, no, that's statistics, that's completely wrong. Okay, that's not the way.
Okay. It's still subjective. Huh? It's still up in
Yeah,
the
it's
air.
really subjective. Yeah. I guess that my position here is I'm in the middle, or I like to think that I am in the middle. So I guess that statistics are going to play an important role. And this is just because we have a huge amount of data available online. We have these unsupervised approaches that we can use to basically to use all of this data. So why not doing it? But I guess that we also need some kind of linguistics, because otherwise it's like just trying to solve the natural language processing problem by brute force is not going to be feasible. It's not going to be feasible, and it does not make sense.
So to kind of build on that kind of statistical versus linguistic comparison that you made, so you're saying that we've gone through more of a statistical phase most recently.
Yeah.
Can you kind of describe, when that started, and what are some of the problems that that approach was able to solve, and what tools or what innovations kind of made it possible to even use that approach?
Yeah, I guess that it started in the 90s, and it get with support vector machines, and it got a new pump on recently with deep learning. Okay, previously to support vector machines, we have these statistical based classifiers. Some of them we review them in class, right?
Mm-hmm.
But it was basically about these expert systems trying to create these complex grammars, or trying to create these databases, these lexical databases such as WordNet, in which many people was working over there trying to to summarize in some kind of dictionary or some kind of lexical database all of the information about the world. Then we had Wikipedia, and we started to collect information in Wikipedia. But I guess that we discovered that natural language processing is really complex, and even if we are able to define some grammar, this grammar is not going to generalize, and this grammar could work for specific fields. These expert systems were based on trying to solve, for example, natural language problems related to I don't know, to medicine, or related to a really particular and close field, but they did not work. Yeah. And then support vector machines in the 90s, they appeared, and we started to see, okay, this classifier is really nice. We can leverage a lot of data. The result that we are getting, they are just impressive. So let's try to use that. So with support vector machines, we were able to improve a lot some classification tasks, such as text classification and this kind of approach, sentiment analysis, all of the things that has to do with, I have this piece of text, this piece of natural language, and I need to assign some kind of label to it. Mm-hmm. But again, we face the problem that, wow, I mean, we can do complex things with that, but we cannot actually, for example, have a discussion with a natural language processing system, or we cannot read a piece of text and understand this piece of text, okay? So when it seemed that support vector machine was giving up, and we started to move again to this linguistic approach, then it was like 2006, and deep learning kind of appeared. Okay, deep learning first appeared more related to image classification. They were able to crush these image classification benchmarks, and they were able to reduce these error rates from 15% to 3% in ImageNet, and everybody went crazy about deep learning. Okay, mm-hmm. Deep learning is not a new technique; it's basically the same artificial neural networks that we were discussing in the 60s, but with on steroids, with more size and more data to train.
Right.
And the approach was like, okay, that works for image classification, which is a really complex problem. Let's try to do that in natural language processing. And what they were expecting is that they just going to crush these natural language processing benchmarks. And they did for some particular tasks, such as language modeling. Language modeling is just the task, or if I am giving you 10 words, or if I am giving you this sentence, you have to predict the next sentence. Or if I am giving you this piece of text, you just need to predict the next paragraph or something like that, okay? So they were able to do that pretty well, but there are some other natural language processing tasks, such as, again, conversations that even if you have deep learning, you are not able to engage in a proper conversation with a natural language processing system. Right. Especially if you want to apply that. Imagine trying to create some customer service solution based on deep learning. It's basically not going to work. Okay. Mm-hmm. So I guess that this is more or less the history of the field in the last 20 years. And we have discovered that deep learning is great, but it's not going to solve our problem. It's not going to create artificial intelligence. So let's go back to square one and start to discussing about what kind of linguistic things we can do. Okay.